Now we're going to take a quick look at the graphs of the parent cotangent and cosecant functions. These are the last two of the trig functions that we need to take a look at the graph of. First, we'll look at the cotangent function. And again, everything comes right from that unit circle. We take those exact values, we put them into the cotangent function machine, we get a corresponding y value, and now we have points that we can graph in the plane. And much like tangent, cotangent has vertical asymptotes as well. It has a vertical asymptote here at negative pi. The y-axis is a vertical asymptote for the parent cotangent function, and there's a vertical asymptote at pi. It has repeated pieces just like tangent does, but instead of going through the origin and having vertical asymptotes at every pi over 2 along the x-axis, it has it at every pi interval. And we usually just graph this piece of the parent cotangent function. And it has a 0 at pi over 2. It travels just to the right of that vertical asymptote, curves over here, goes through at 0 on the x-axis, and then travels just to the left of that asymptote. The period for the parent cotangent function is pi. The domain is all real numbers except integral multiples of pi. That should say integer. I don't know where integral came from. That's what I get for borrowing PowerPoints off the internet. So all real numbers except integer multiples of pi, and the range is all real numbers. So there's what the parent cotangent function looks like. Now remember, cotangent is defined to be cosine over sine. So we can find those values very easily. If we want to graph transformations on the cotangent function, here we would have what would be equivalent to amplitude. So this is actually going to compress the outputs of the cotangent function. This is going to affect the period from the parent cotangent function. So if we had the parent cotangent function, y equals cotangent of x, and it has a period of pi, that means that our formula that we're going to use for a period change would look like this. And so what we're going to wind up doing here is, for this function, it would be pi over, our b value is pi over 2. And so that bottom would flip, we would multiply straight across, and that cleans up to 2. So the period for this function would be 2. So there we are. All right, and then all we do is just compress that function. We don't have, for this particular function, we don't have a phase shift. So we're just going to continue to put our vertical asymptotes there where they are. So we have a vertical asymptote at 0, and this is hard to see, but this is a vertical asymptote between pi over 2 and 3 pi over 4. So, and then we just draw what the parent function looks like, taking into account that we're going to have a compression on that function. So now let's take a look at the parent cosecant function. And much like what we did for secant, we're going to do the same thing for cosecant. So here we have y equals the cosecant of x. That's the blue function here. But we're always going to graph the co-function, the sine function that goes along with cosecant, because again, at the maximums of the sine function, cosecant has these pieces that follow along its vertical asymptotes, and at the minimums, cosecant behaves like this. And then we are interested in the zeros of our tangent function, because at all those zeros is where cosecant is going to have a vertical asymptote. So we want to always graph the corresponding sine function if we're going to graph any transformations that go along with our cosecant function. The period for cosecant is 2 pi. The domain is all real numbers except integer multiples of pi. The range is all real numbers such that our y outputs are less than or equal to -1 or greater than or equal to +1. So there it is in interval notation, and that's what we're used to. We have vertical asymptotes at multiples of pi, and we can see because it is symmetric to the point of origin. It's a little hard to see, but it is symmetric to the point of origin. Therefore, cosecant is an odd function. So if we were going to graph some transformation of the cosecant function, like y equals the cosecant of the quantity x plus pi over 4, the first thing we're going to graph is that corresponding cofunction. So we're going to take the sine function and we're going to pick it up and move it pi over 4 to the left in the plane, which you can see has been done here. There's the parent sine function, but it's been translated pi over 4 to the left. And so we're going to look for the maximums on this function and the minimums on this function. And that's where the pieces of this cosecant function are going to be drawn. And they're going to travel right along those vertical asymptotes. And remember, those vertical asymptotes come from the zeros of that corresponding sine function. So there's all the pieces from negative pi over 4 to 9 pi over 4 that I would draw for this cosecant function. So we do exactly the same thing graphing cosecant that we did graphing secant. We want to graph that parent cofunction. For secant, that was cosine. Here for cosecant, that's sine. And once we handle all the changes for this function, then this function is very easy to graph. So that's it for the parent functions of cotangent and cosecant. Come to class next time and we'll practice graphing these functions.